congratulations for making it to the last lesson of our Math 2 class with Teacher Marian, Quarter 4, Module 1, with the topic Deciles and Percentiles. For this lesson, we will get to know the other commonly used measures of position. These are deciles and percentiles. The deciles are the 9 score points which divide the distribution into 10 equal parts. Each part represents 1/10 or 10% of the data set and are denoted as D1, D2, D3, D4 up to D9. While the percentiles are the 99 score points which divide the distribution into 100 equal parts so that each part represents the data set. It is used to characterize values according to the percentage below them. For example, the first percentile or P1 separates the lowest 1% from the other 99%. The second percentile or P2 separates the lowest 2% from the other 98% and so on. Looking at this figure, we can see the relationship of quartiles, deciles, and percentiles. It can be observed that Q2, which is a median, has equal value with P50, and P50 is equal to D5. Therefore, we can say that in a distribution, D5 and P50 are considered to be at the median. Moreover, the first decile is the 10th percentile or P10. It means 10% of the data is less than or equal to the value of P10 or D1, and so on. Now, let us proceed to finding the decile and percentile value for ungrouped data. Still, we will be making use of one method, which is the Mendenhall and Sinsich method. They are computed in the same way that the quartiles are calculated. So in using Mendenhall and Sinsich method, we need to follow these steps. Step 1. Arrange the data in ascending order. Step 2. Find n or the total number of elements. Step 3. Calculate the position of deciles or percentiles using the formula. In finding the position of the indicated deciles, the formula to be used is dk is equal to k over 10 times the quantity of n plus 1, where dk is the indicated decile, and k, which could be equal to 1, 2, 3, 4, up to 9. So here, the denominator is 10 because decile divides the distribution into 10 equal parts. Similarly, for percentiles, we will be making use of this formula. Pk is equal to k over 100 times the quantity of n plus 1, where pk is the indicated percentile, k, which could be equal to 1, 2, 3, 4, up to 99. So, the denominator is 100 because it divides the distribution into 100 equal parts. For the value of n, it is the number of cases or scores or data. We always have to remember if the resulting value has a decimal part, we must round it up to the nearest integer. However, if the resulting value falls halfway between two integers or has a decimal part of 0.5, you have to follow these rules. If the indicated quartile falls on the left side or less than the median, round it up. And if the indicated quartile falls on the right side or greater than the median, round it down. So, for example, the resulting value of the position of D7 is 3.4. The computed value 3.4 becomes 3 after rounding to the nearest integer. So the decile value is on the third element. If the result of the position of P1 is 5.8, then round it to the nearest integer, which is 6. However, if the result falls halfway between two integers or has a decimal part of 0.5, we need to locate first where the indicated decile or percentile falls in a distribution in order to decide whether to round up or round down the resulting value. If we have the position of D4 is equal to 6.5, then we have to round it up to 7 since D4 falls on the left side or less than the median, D5. And if P70 is equal to 5.5, then you have to round it down to 5 since P70 is on the right side or greater than the median, P50. And for the last step, look at the arranged distribution. So you have to look for the value of the resulting element in step 3 in order to find the indicated decile or percentile value. So now let us proceed to the example. Using Mendenhall and Sinsich method, find the third decile and 30th percentile of the following test scores of a random sample of 10 students. Step 1. Arrange the data in ascending order, so from least to greatest. We have here the arranged data. Step 2. Find n or the total number of elements. In this example, the number of elements is stated in the problem, so our n is 10. Step 3. Calculate the position of decile using the formula dk is equal to k over 10 times the quantity of n plus 1. And pk is equal to k over 100 times the quantity of n plus 1 for percentile. Since we will be looking for D3, we will substitute 3 to the variable k in the formula and 10 for n. Let us do the operation. Position of D3 is equal to 3 over 10 times the quantity of 10 plus 1. 10 plus 1 is equal to 11 times 3 divided by 10. So the resulting value is 3.3. The computed value 3.3 becomes 3 after rounding to the nearest integer. The third decile value, or D3, is the third data element. Now, let us look at the third element in the data set in step 1. We can see that the value of the third element is 20. So D3 is equal to 20. Similarly, position of P30 is equal to 30 over 100 times the quantity of n plus 1. This is after substituting 30 to the variable k in the formula. Next is to substitute the value of n, which is 10. So we will have the position of P30 is equal to 30 over 100 times the quantity of 10 plus 1. 10 plus 1 is equal to 11 times 30 divided by 100. So we will arrive with an answer 3.3. The computed value 3.3 becomes 3 after rounding to the nearest integer. Therefore, the 30th percentile value, or P30, is the third data element. Let us look at the third element in the data set in step 1. We can see that the value of the third element is 20. So, P30 is equal to 20. As what you have observed, D3 and P30 has the same value. It's because D3 and P30 falls on the same point in a distribution. And that's all for this lesson about deciles and percentiles for ungrouped data.
Maraming salamat sa panunood, mga kaalamat!